Thank you for being here today. Welcome to our webinar on sustainable buildings, insights, drivers, and real-world examples. We have a great team here to share information with you today. So before we get to that, I'm just going to share a few things about the Sustainable Business Council. Most of you know us, but if there's anyone new listening, our mission is to accelerate the adoption of sustainability by integrating it into business, operations, and strategy that helps drive long-term impact. So we primarily do this through membership. Businesses, individuals, students, nonprofits can become members of our organization, and our member benefits you can see here. They're educate. We host ongoing webinars like this. We're about to launch a roundtable series, and we just set a date for our annual conference, which is November 18th. So mark your calendars, more to come on that. We also have our Green Masters program. We also facilitate connection and love to share our members' stories. So I mentioned the Green Masters program. This year we have some fun updates to the program, which we're getting ready to open. If you haven't heard about the Green Masters program, it's an online tool for businesses to set your sustainability priorities through a materiality process, and then develop systems for the ongoing tracking, measure, and monitoring of those. And new this year, we have a built environment topic that was developed in collaboration with USGBC, and it aligns with and acts as a stepping stone to the LEED V5 certification. So sort of no matter what your building portfolio looks like, large, small, owned, leased, the new built environment category provides a step-by-step pathway for improvement. So this topic is good if you found any of standalone Green Masters program topics like energy, greenhouse gas, and water management too in-depth, but still want to prioritize building-related sustainability efforts. So the new built environment topic ensures that the Green Masters participants can measure, manage, and improve building-related impacts using the same best practices that leading organizations are implementing. So that's a brand new topic that we're launching this year. So excited about that. We do offer sustainability services if anyone is interested in going sort of faster, further, or needs specific support. Also, we have our Cool Choices member game. If you're an SBC member, we encourage you to consider playing Cool Choices this year. That game will start on April 6th. Registration is currently open. You can have up to 15 players from your organization, or you can, if you're an individual, you can just join another team. So we encourage you to play. Just a few upcoming events. I mentioned Cool Choices. Also, I'll be participating in the B Corp Champions Retreat in Milwaukee this year. USGBC also is leading a walk of some of their buildings, some cool buildings around Milwaukee. We are hosting an Earth Day social in collaboration with a few other organizations. That'll be right during the Champions Retreat. That's right on Earth Day of April 22nd. We'll have our next member networking on May 8th. And then our next in-person event will be in June, on June 17th. And that'll be a data holdings tour that's located in Milwaukee, but it'll be a great sneak peek at their data center that's sort of nestled in Milwaukee. So just thank you to our sponsors who make these types of events possible. Today, I'm recognizing Mercury Marine and G&E, that's Madison Gas and Electric, Kohler, and Land's End. All right, without further ado, I get to now introduce to you our great speakers. So with us today, we have Corinne Hafel, the Director of Market Transformation at USGBC. We have Dave Hubka, sorry about the typo, Dave.
That's all right.
I looked at that, I was like, nope. Practice leader for sustainability at EUA, and then Andrew Holstrom, business and project development at Arch Solar. So I'm going to hand it over to Corinne, who's going to moderate the conversation.
Thank you, Jessie. And thank all of you for making the time to be here today or to watch this webinar after the fact. It really is great to be with so many people who are shaping what sustainability looks like in Wisconsin and beyond. So I'm going to take just a couple of minutes to set the stage by talking about where the sustainable building practices are headed and to share a USGBC broad perspective on performance and whole building outcomes. So for more than 30 years, the U.S. Green Building Council has worked to transform how we design, build, and operate buildings. So today, that mission is really more important than ever. Sustainability is no longer just about what we need to do to reduce environmental impact. It is about strengthening our local economies, improving community well-being, and helping businesses succeed long-term through better building performance. Next slide, please. The LEED Green Building Rating System has always been our framework for advancing that work, and has become a world's leading green building rating system because it provides a clear, holistic, and third-party verified structure for delivering those sustainable, high-performing buildings. And with LEED v5, we are making one of the most significant updates in the program's history. Next. So the LEED v5 system is really built for impact. It is focusing on 3 areas that matter the most right now in the building industry. So that's cutting carbon, it's improving quality of life, and protecting and restoring natural ecosystems. These themes run throughout the entire LEED rating system, from the credits to the metrics to the new dual view scorecards that help teams understand how each design strategy contributes to those larger goals. Next. One of the most important shifts is that LEED v5 is centered on carbon. So it provides a clear step toward near zero carbon buildings by addressing operational emissions, embodied carbon, refrigerants, and even transportation impacts. It also strengthens resilience throughout the rating system because climate-related disruptions are really no longer an abstract idea. They are very real. We know this from national data. In fact, the U.S. Chamber of Commerce released a study recently that stated that every dollar that was invested in resilience and preparedness actually gave communities $13 in avoided damages and economic loss. So we're talking about some significant risk aversion. So that is really an extraordinary return, and it underscores why resilience must be integrated into decision-making from the start. Next. So LEED v5 also aligns with where the overall market is heading. So organizations are adopting climate targets, they're publishing ESG reports, preparing and emerging regulations. LEED gives those organizations a credible way to demonstrate progress while still keeping the focus on what matters most, the outcomes. At USGBC, that is really our priority. We want to ensure that decisions about sustainability lead to real, measurable improvements in how the buildings perform. And this brings us to the whole building outcomes. This is a theme that you're going to hear throughout today's conversation, that is electrification, solar, envelope improvements. These are not standalone features. They only work as intended when the entire building is considered as a system. And at USGBC, we see performance as the result of how all of those pieces interact. The envelope, the loads, the systems, the controls, and how the building operates day to day. LEED v5 is designed to help teams optimize those interactions so that the strategies actually deliver the outcomes that they are promising. Next. So this is really important here in Wisconsin. Our climate, our energy mix, our seasonal extremes, all of these things shape how buildings need to perform. Electrification, resilience, and efficiency strategies all have to make sense in this context, and that requires early, thoughtful coordination across design, engineering, and operations teams. And that's exactly why today's conversation is so valuable. We're going to explore the big picture drivers behind electrification and solar and how whole building thinking is influencing real projects and how teams are navigating both opportunities and challenges on their path toward low carbon, high performing buildings. So with that, let's shift into our first conversation of the day. Dave, I'd like to start with you. As an architect, how is whole building thinking influencing decisions that you are seeing right now?
Yeah, good question. Whole building, it takes all of us. We've been talking about this for 20 years plus since the inception of LEED and third-party rating systems, and it's It's required now. These sustainability designs are getting so much more complex. There's so many different incentives available that we can't rely on one sustainability consultant or one architect to know it all. With the adoption of our state's recent code, the Energy Code IECC 2021, there's energy credits, there's commissioning requirements both for MEP and building envelope. That we can't be isolated anymore and be successful. We have to integrate the engineers, the architects, the contractors, the PV suppliers. We need them all at the table to help inform decisions for better buildings. A good example is us as an architect. We run the ComCheck since forever. But now with these energy credits, we need to invite the MEP engineers to get their systems in, because that's what's used to calculate the energy credits. And if we don't have their information, we don't know where those energy efficient strategies are coming from that are mandated by the code. So now more than ever, we need to integrate all. And just internal to EUA, on each and every one of our designs, we ask the question, can we put PV on the project? Does it make sense to go electrification? What's the cost implications? And even if the owner says we don't have PV in the budget, the next step is we say, can we make it PV ready? Can we include a structure that we know in 5 to 10 years will account for it? Can we talk to our electrical designers to, put some designs in place that at a future date, it's literally plug and play. So once again, we can't be siloed anymore. Designs are getting so much more complicated. We can't put it on one person's shoulders anymore. We need everybody and everyone to help contribute. So.
Fantastic, Dave. And I think the other aspect of that is that integration and that early conversations about planning for the future, if it's installed now or later, also has real cost implications as to when those ideas are introduced into the project. So Andrew, from the solar side, what does it look like when you're talking with owners?
So I think we've seen a big shift recently more into an operational conversation, as opposed to historically being a capital conversation, right? So kind of like, Dave was hinting at, like, these buildings are living, breathing things, and we really have to understand how they work and look at it from if they're switching to electric heat pumps, like, how are those calling for power and energy? When are they calling for power and energy? And that allows us to design a system that fits the specific need. But it's, like Dave said, we really got to partner together, because if you just have a HVAC contractor come in and retrofit and you aren't really sure what the output's going to be, it's really hard to plan for that. It varies widely from organization to organization, and the sustainability drivers, whether they're internal or external.
Fantastic. That brings me to the idea that many organizations are now making public commitments to reduce or eliminate Scope 1 emissions, right? And that's some of the drivers that a lot of our teams are dealing with, and it's changing how teams are thinking about energy strategy, electrification, and on-site generation. This is an important thing that Lead B5 is also working to shift that focus from cost and to future source energy. Dave, how is this showing up in projects that you're supporting right now?
Yeah, good question. We do have some municipalities, several clients that, come to the table and say, we like you, EUA, to design us a sustainable building. And we're more focused now on Scope 1 emissions. We want to eliminate Scope 1 emissions. I hear that again and again. And we get off the call and then everybody turns around to me and says, Dave, what's Scope 1? And I say, Scope 1 is the natural gas consumption. So if they're focused on eliminating Scope 1, they're looking at electrification. And if we look at electrification, we got to find ways to offset that. So PV is part of the discussion. And like I said, there's a couple of municipalities that have raised their hand to say, we're going to be Scope 1 neutral by 2030 or 2040. We have some big clients, global clients, and we do their HQ projects. And it seems what I've learned too is when big companies are going to build and design a new headquarter building, they want to tell the sustainability story and walk the walk. And that's where these Scope 1 carbon discussions I'm seeing again and again. And what used to be 20 years ago, energy cost payback, it's still there. But the driving force now is that carbon and how we can eliminate scope 1, and then the grid's going to clean up in the next 10 to 20 years, and scope 2 hopefully will come down as well.
Fantastic. Andrew, I'm sure you're seeing some of this as owners are exploring solar in the context of these commitments and working with your teams.
Yeah. I think Dave said it best, right? It's difficult right now with such a dirty grid and a very high fossil fuel mix in the Midwest. You know, we can shift from scope 1 to scope 2 with electrification, but if you're pulling that electricity from the grid that is right now dirty, you know, we're still working on as an area of the United States is cleaning that up. So to reduce the overall emissions, you need to integrate things like on-site generation, you know, whether that's solar, wind, or even utilizing like geothermal heat pumps.
So that leads me to start thinking about, you know, what we're seeing as far as architectural solar and other design integrated solutions as they become more common, right? They're really influencing planning in ways that we did not really see even a few years ago, right? Andrew, when you work with teams looking at these solutions and real projects, what are you seeing right now that is shaping these early feasibility or design conversations?
Yeah, so most architects, and I say most because there's some that aren't, are doing solar ready buildings. Sometimes at the request of their customer, or in Dave's case, they're just doing it out the gate. And don't get me wrong, that's great. But sometimes with these high energy needs, the rooftop real estate isn't enough, and it's hard to come by in more urban environments. So we're starting to see a shift into these dual purpose systems, right? More carports, pergolas, awnings, some cladding integrated stuff, right? And we're seeing vertical where historically it's been stretched like this. It's starting to stretch like this, which is really cool to see. But to that point, right, that involves Dave and I working together from day one and saying, hey, how can we do this so, you know, these solar windows we're putting in are going to function properly and have the same requirements, whether it's like low E or just structural integrity as the more traditional options.
Dave, from the design side, when these technologies are showing up early, does that influence how you're thinking about the building as a whole?
Yeah, I mean, absolutely. We don't want to design an energy hog and then say, Andrew, you're up, save the day for us. It's quite the opposite. And Andrew, you might have to close your ears, but when PV shows up, owners say, how little do I need to meet my goal? How little do I need? So it kind of really pushes us to optimize the glazing, optimize the insulation, optimize the HVAC, electrical and plumbing, control strategies, because we want to hand Andrew the most energy efficient building possible. So he can maximize the impact his solar has on the building. And then on the back end is to make sure that they're commissioned. You know, I've been involved with a project where they had a whole field of PV panels, and for the first year, they didn't know that a good chunk of it wasn't on until they, you know, took a look and said, wait a second, this is less than they told us. And then they went out and said, oh, yeah, it was nearly half of the PV panel wasn't connected correctly. So we say we also make sure that they're connected correctly, commissioned, and you are getting the electricity that you're expecting. So it all comes together that way. And once again, the punchline is we don't want to design a code compliant building, the worst building possible, and then hand over an energy hog that PV can save the day. We're all in this together.
You know what? Hearing this sets us up perfectly for a few concrete examples. So Andrew, why don't you just take us through a few projects that show what this looks like in practice, please?
Yeah, so thanks, Corinne. First, I feel like it's important. We're talking about electrification, energy, power, and it's really important to understand the difference between those two, right? So, you know, someone in this industry, like I'm sure many of the people on this call know, there's a difference between power and energy. And so conceptualizing that, right, you would have a bucket of water. So these 3 buckets of water here, let's say those are kilowatt hours. So that is energy, right? And then power is the rate at which you're pouring out that water. So if it's a trickle, it's a pretty low power intensive draw. If it's a dump, it's pretty darn heavy. Another way to think about it is like a speedometer with power, right? That's how fast you're going. So when we switch to these electrified buildings, and we're talking about solar generation for that matter, you want to make sure you're trying to align that speedometer to the same speed. All right, let's hit the next one. And that's a lot of power right there, right? So all right, so I mentioned architectural solar, right? And when I first started learning about it and conceptualizing it, I was like, oh, this is going to be a space station, or this is going to be some floating blimp in the sky that has solar panels on it. But really, I mean, what we're seeing right now is the first functional applications of it. Like this example, this is at a business down in Racine. So you have your traditional solar that's roof mounted in the lower section. And then you have a PV awning that's functioning as a dual purpose to both shade the seating area in the summer months as well as produce power. And you can see they even went as far as to integrate a gutter that's dripping down into a green roof. So that's a pretty simple example of architectural solar and probably what we'll be seeing first, especially here in Wisconsin. And then let's roll on to the next example, right? Talking about how electrification and PV really commingle together and create a good solution. So this is the Milwaukee Community Sailing Center down on the lakefront in Milwaukee that does not have a gas service. Part of it was the complications of getting it from far away down here, and the other side was the desire to be a sustainable building. So this building has 14 300 feet deep geothermal wells. It's reusing recyclable cladding, high performance windows. The awning design lets light in the winter and keeps it out in the summer. And we have a 40 kilowatt pour, of the bucket for the PV array that's generating 45,000 kilowatt hours annually, right? So that's our little buckets we talked about. And it's certain that, there's certainly 100 different ways to chop it up and explain it, but I feel like this example at least sheds a little light on what they can look like together when they're done right. And while this building, when it was constructed, was kind of ahead of its time, I think we're going to see a lot more buildings with this same style of architecture combined with systems and on-site generation going forward.
Fantastic. Both of you have sort of tickled this topic already, but we're really seeing organizations make sustainability decisions from very different viewpoints, right? Finance, operations, design, and leadership. They're all weighing different risks. So electrification fits into this because it is not a simple equipment change, right? It's a decarbonization strategy that only works when the whole building supports it, including envelope performance and how systems interact. So Dave, from an architectural perspective, what stands out to you in these early conversations? Oop, you're muted, Dave.
Sorry about that. Thanks. Yeah, with these discussions of electrification and eliminate scope 1 and some of the examples that Andrew had put up there is, selfishly speaking, I love to see PV because you can see it. There's a lot of sustainability you can't see when you walk up to the building. You don't know what they're doing with their water. You don't know what the solar heat gain coefficient is. You don't know what the efficiency of the boilers. There's so much you can't see. But when you see that nice panel array of photovoltaics, you know that something special is going on, or you believe something special is going on if it's connected and commissioned. But when we show up as an architect and a design team with sustainability goals, primarily electrification, in the discussion, I look at what's the programmatic space type. Is it a factory? Is it a school? Is it an office? Obviously, climate zone's a big driver. Cold climates really struggle with electrification compared to Houston and Miami and Atlanta. That's a big driver. Also, the grid, as Andrew mentioned, we don't have the cleanest grid here. And, some of the shock people get is, Dave, I thought electrification was cleaner and the right thing to do. It's like, well, our grid's not there yet. It's getting there, but our grid here in the Midwest isn't quite there yet. We've had the fortune of working on some projects, some really cool projects actually in Quebec. And I learned that Canada has extremely clean electricity and very cheap electricity. So electrification up there made quite a bit more sense. So it's really the future forward thinking design strategy where it might not make the math today, but our 10 to 20 years, the electrification, the math will make sense. Our grid's getting cleaner. And we're just kind of preparing our buildings for what's coming in the future from the grid is what we're seeing.
Andrew, how does it appear when owners are considering on-site generations?
So for some sectors of business, it's coming down to the operational spend, whether that's from shifting to electrification, already having it, or not doing it at all. And that's the end goal, right? And the way I kind of look at it is that you have your tool belt, and solar is a tool that fits in there to do that. So it's not right for everybody, right? And that's where we have to evaluate, is this a good site? Is your consumption profile aligned with a way that solar can help you, or battery storage for that matter, right? And I feel like that's where Dave gets to have a little bit more fun than I do sometimes, because he's got he's got a little tool that he's like, hey, let me open up this toolbox with 80 different drawers and pull some levers to help make that happen. And then when that happens, right, we can typically find a situation where, hey, now solar makes sense, right? But it's finding the right tool for the job and making those fixes first on an operational side, right? And we can't argue with the cultural value, which from a leadership standpoint, sometimes is the main driver. Specifically with the like building integrated architectural solar systems, right? They want to illustrate to their employees like, hey, we are a green place to work. Sustainability, while 15, 20 years ago was less common, I like to think now it's what the cool kids are doing.
Exactly. I like to think that too, Andrew. Dave, I think you touched on this a little bit earlier, but I'd love for both of you to reflect on it a bit more, because electrification really requires a building to actually support it, and that envelope and the load management definitely influence the outcomes just as much as the specific equipment that are there. So, is there anything you want to add on that topic?
Yeah, I mean, not to spill the beans from my slide deck coming up here in a second, but when they say electric, all electric, I obviously say PV, but is there geothermal a possibility? You've got to evaluate heat pumps. You've got to look at control strategies. You definitely have to commission it, and it's all got to come together. Once again, we just don't want to throw PV at an electric building. And to Andrew's point, I do have a lot more tools in my tool belt because I do work with our architects, our electrical designers, our mechanical designers, our plumbing designers. I'm on calls with the owner. We can do some napkin math for what the energy impacts are, the carbon emissions are with these decisions, but it's all of the above. So electric, PV, geothermal, heat pump, optimal glazing, and it's energy recovery everywhere we can get it. It all comes together. And then once again, like I said before, Andrew, we want to make your system as small as possible to offset as much as possible. That makes sense for the site and the client and the project.
Climate matters, right? So, what you might install in a mild climate probably doesn't translate into what you would install here in Wisconsin. And this affects system choice and ultimately the operational expectations. How does that look in your decision-making process when you're making recommendations to your teams and moving them forward?
Well, I always say math is math. It's going to get really cold here in Milwaukee. I, past life worked for a large property management firm, part of the sustainability team. I did the lead existing building program all over the country. We'd show up to a big skyscraper in Miami and I'd say, where's your boiler? And they're like, what's that? It's all electric. And then you go to Minneapolis and it's -15, -20 in the winter. So climate is a huge driver. That's one of the drivers. And like I said, math is math. So we'll just do the load profile of how much energy we expect to consume. We convert it back and forth from electricity to natural gas. There's a new term called spark spread because electricity is more expensive than natural gas. And like I said before, that's one of the shocks with folks is, wait a second, I thought this was the right decision. Well, it is. It's future thinking, but electricity will be more expensive. And our grid's not as clean as natural gas yet, but in 10, 15 years, we're going to get there. So if you want your building to be on for 50 plus years, that's what sustainability is about. It's making a decision now and 30 years from now, looking back and said, that was a good decision. Now, some of these decisions are tough right now, but hopefully in the future, we'll be proud of our designs and our decisions.
Well, and to that point, Dave, if you're building a building now, knowing that the electricity grid will be cleaner, retrofitting an existing building to go all electric, what sort of undertaking would that be if that decision wasn't made at the time of new construction?
Yeah, exactly. Where I talk with our electrical designers, they say, yeah, we can make it all electric ready. We can make it solar ready. We can set it up for whatever you want. But if you don't tell us to, if we don't drive to that, you might be in trouble in 10, 20 years when you try and flip out an old gas boiler or gas heating to all electric, because now you need a new service. The dollars show up a lot more staggering if you don't future prep it for all electric.
Fantastic. Andrew, anything to add to this?
Yeah, no, I think, Dave, let's keep shrinking those system sizes for solar. I'm kidding. But yeah, I mean, in the Midwest, right? Like, it's really easy to check the box. Like, we have solar, or we have a solar production system on our roof. But designing those systems to work in the Midwest, one, you can work with the building, but right, we get snow. And with the sun angle dropping to like 22 degrees in the winter, we've got to at least try to orient and design the system to be able to curb that a little bit. So when January rolls around, you're not like, hey, is my solar system working? And you're like, oh, well, they're really low to the roof, so it's covered in snow. We'll see you in March.
Oh, goodness. Yeah. I think this would be a great time, Dave, for you to perhaps walk us through your all electric office example and sort of bring visuals to this conversation.
Yeah, absolutely. So just to tee up this discussion, starting in the sustainability world, gosh, nearly 25 years ago, it was always energy costs, energy costs, energy costs. We do the energy models and what's the cost savings, cost savings, cost savings. But now with LEED V5, V4, and last, I guess, 5 to 10 years, it's carbon, carbon, carbon. It's what's the carbon emissions, what's the carbon reductions, what's the future energy source value. And I put this slide together because one of my friends said, Dave, carbon, what isn't that just pencils? Because the tip of that pencil, that graphite carbon, that's pure carbon. So we're saving pencils? I said, no. It's not our number 2 pencils, that's carbon. So if you go to the next slide deck, I wanted to explain this because it took me a while to get my head around this too. So we say carbon as a general term for atmospheric greenhouse gases. As you can see in the cloud there, it's all sorts of gases. Now the CO2, the carbon footprint, that's the vast majority. So instead of calling it all these different chemicals, compounds, you name it, we just refer to it as carbon. We can't quantify it as metric tons of carbon dioxide equivalent. So carbon footprint, that's kind of some of the behind the scenes, what actually is in it for greenhouse gases. And then we've also delineated it into scope 1, 2, and 3. Scope 1 is that on-site energy or emissions pollution, which is combusting natural gas for boilers, and also any fleet vehicles. So that's what drives the discussion with clients and municipalities to say, we want to eliminate scope 1. So if we are not emitting anything, we're good, and we're hopeful and optimistic that the utility company will clean up their grid. And that's scope 2. That's the coal-fired power plants, or that's the utility that provide electricity to your buildings. And what's interesting is I'm watching the grid. It's the EPA website, and you go to the different places in the country, and it will show you how clean or how dirty your grid is. And just in the last 8 to 12 months, our grid has gotten about 6% cleaner. So what's fascinating is like, oh, this is working. So I'm watching that and seeing how it's getting cleaner. So that's scope 2. And then scope 3 is everything else that comes along with it. Some clients are focused on that, but that's kind of a little bit outside the scope of architects and engineers and designers and PV. It's more corporate company policies, but I just wanted to pull that apart to make sure everybody's aware, because I was confused about this as ever. And if you go to the next slide, it's a visual of what 1 metric ton of carbon dioxide equivalent looks like. It's a pretty big ball. So if you hear a number that's 10 or 20 or whatever the number is in metric tons carbon dioxide equivalent, doesn't really mean anything because we don't have a visual, but that's a visual of how big 1 metric ton of carbon dioxide equivalent is. Next slide. So we did a project, and it was a LEED project. And so we did that LEED energy model, which is a very comprehensive model, and it was a very comprehensive review by the GBCI, about a 80,000 square foot office building in northern Illinois. So it's a cold climate. And what we found with this very efficient design from the architectural side and MEP side is that it performed 28% better than the LEED baseline. The heating itself performed 48% better than the LEED baseline. And the savior here was we had rooftops up, to serve the whole building, but they weren't just normal rooftops, they were heat pump rooftops. So the heat pumps were fantastic. Another thing too is, if you don't know what a heat pump is, a heat pump just trades energy around throughout the course of the year. So these particular heat pump rooftop units, when it would say 30 degrees out, instead of engaging natural gas, the refrigerant cycle would run backwards. So it was dumping heat into the building. What was, it's just very surprising to me and our team was, wait a second, when it's 30 degrees out, you can heat the building with outdoor air? Yeah, you can. So these heat pump units ran the refrigerant cycle in reverse and pulled some heat out of that 30 degrees and put it back into the building. So it's just fantastic design. So that kind of goes back to, if we're looking at net zero goals, eliminate scope 1 emissions, and we're turning to the PV supplier like Andrew, I highly recommend we look at the heat pumps to make this as small of an energy consumption as possible. Next slide. I did some math here too to compare to different systems. So the all-electric baseline cost $87,000 and estimated to emit 448 metric tons of carbon dioxide equivalent. Our design consumed about, or cost about $55,000 a year in utility bills and polluted 282. So that's a great reduction from the LEED baseline. A standard rooftop unit's a little bit less, and a little bit less polluting, and that's where people get a shock. It's like, wait a second, if you just did standard, it'd be better. Today, because number one, natural gas is still cleaner than our electricity, and natural gas is still quite a bit cheaper than electricity. But if we did a dual fuel heat pump, that's another option we can go to. So there's a lot of different mousetraps out there. So what we'd like to make people aware of, as you go to electrification, you're going to eliminate scope 1 emissions, the grid is getting cleaner, and then somebody will always ask me, and I always tell them I don't know. They ask me, will electricity get cheaper in the future? I don't know, but if I was a betting man, I'd say no. So those are some of the numbers we had seen on this project. And once again, owner says it must be sustainable. Eliminate scope 1. We want to market our sustainability with a LEED certification. We got LEED silver on this, and we did an all-electric building with heat pumps in a cold climate. So that's how some of the numbers shake out. If you go to the next slide too, because we're an architecture firm, we committed to AIA 2030. We're going to reduce our designs to zero. There's some reasons that we can't get to zero without the help of Andrew and his PV. So we can design a very efficient system, but there's no AIA 2030 glass to get us to zero. So if we design a very efficient building with good glass, good glazing, good insulation, good roofs, walls, good MEPs, control strategies, this graph tells us we still need about 50% of PVs to offset the remaining energy consumption to get us to zero. So we're working our way there. The last slide I did have is just a super simple graphic, is how close could we get to zero? What's the path look like? And I just put this together for our team internally to say it's going to be a combination of photovoltaics on the roof or on the site. It's going to be some combination of geothermal. There's many different ways to go about geothermal, but something we should evaluate. Heat pumps, heat pumps, heat pumps. We want to trade energy around the building. We want to pull the energy from the atmosphere into the building when it gets colder. We want to do dedicated outside air systems with energy recovery and just optimal glazing throughout. Those are kind of my big ticket keyed up items to get us as close to zero as possible. And what I find fascinating too is the way to see what's coming next is I've read the most stringent energy codes in the country, California Title 24, and that's very efficient. And what's coming and what's out actually in California Title 24 is thou shalt PV and thou shalt heat pumps. So PV and heat pumps are becoming code in other parts of the country. So when you watch the coast of what's happening, it's going to come to Wisconsin in the next few years. So I would bet in 5, probably 10 years, PV is going to be mandate code and heat pumps are probably going to be mandated code as well. So I want to start to think of those systems now and start to incorporate them in our standard sustainable design. I think that's all I had for this slide deck.
Well, thank you, Dave. Andrew, how does what Dave shared show up in what owners evaluate solar alongside electrification?
I think first and foremost, it's, we talked about the energy and power in the bucket. So it's reducing the amount of water in your bucket and then controlling how fast you're pouring out that water. Those are the things you got to do first. If you have to delay solar to really figure that out, in the long run, that's what makes sense. And with the embodied carbon, right? It's, the equipment that's being used for these solar panel systems, right? It has to be manufactured. And so there's been a big push, and it's something we're very conscious of when we buy products is, what is the embodied carbon and what is the ROI for that embodied carbon by installing a system? So you see some manufacturers, right, of the solar panel specifically, where it's 0.5 to 1 metric ton of carbon, right? That carbon emissions that is required to manufacture, 1 kilowatt of solar panels. And so for us, right, too, it's pushing that upstream, and because these are companies too, right, that have these sustainability goals, and it's partnering with ones who are trying to get that number down or lowering it. So in the whole full circle scale of things, as a country and civilization, we can really reduce our impact.
Thank you for that, and highlighting sort of that ecosystem of these, this web that there's no, we discussed how we shouldn't be looking at systems in an isolated way, that these buildings need to be holistic, but the reality is everything that we're specifying and the products and services and all of the businesses that touch these buildings have even more impact on that carbon load and, the well-being of the communities economically, et cetera. So this is definitely not a simple equation, and having the right teammates to help navigate it is important. So before we go into the Q&A, let's just sort of like bring this all together. I guess what is one thing that surprised each of you in the past year, and what do you think others could learn from it in this arena?
Yeah, I guess a project-specific surprise hurdle setback that I learned on that project that I presented, it was brought to our attention from the energy modeler. He called me up and said, Dave, your units don't meet the minimum efficiencies of the code of ASHRAE 90.1. I'm like, how can a manufacturer sell a piece of equipment that doesn't meet the code required efficiencies? So I don't know, but they don't. So I called up the manufacturer and they said, Dave, these are the new units that have R454B refrigerant. They're brand new. So we don't know what their efficiencies are yet. They're being tested. And I'm like, oh, I sure hope they pass. So my point though is with these new technologies, we are learning on the fly. we're staying scared because we're kind of out in front. So that was a surprise to me with these new units. They're environmentally friendly refrigerants, and kind of touching on Andrew's point, we've reduced the operational carbon, but not what's now the embodied carbon of these new systems. There's also transportational carbons that come along with it, and then the refrigerant carbon. So while we fix one item, we might have to work harder on the next item. It keeps us very, very fully employed. That's for sure.
Nice and nimble. Andrew, any thoughts?
Yes, one thing that surprised me this year was the U.S. beating Canada in hockey in the Olympics. I'm just kidding. My wife's Canadian, so I'm going to ride that joke for a while. But in reality, it's been the ramp rate of U.S. solar manufacturing. The industry experts expected that it would take us till mid-2027 to get where we are today. And a lot of that's been driven by the push of, the end user and the people installing and designing these systems. And so I guess what others could learn from it is like, if you want something, like keep pushing. And if you want it done, like team up with other people and use that collective power. And is it going to work every time? No, but keep pouring the coffee and get it done.
Fantastic. So now we're going to get a little, we're going to bring out our crystal balls here. And I would like you to take a quick look ahead, right? So in 2030, what do you think we will look back at and laugh about how we approach these strategies today? Because I know there's other things that we did 10, 20 years ago that I laugh about now. So how does that look in 2030 compared to now?
I think in 5 years, 4, 5, 6 years from now, we're going to have a much better understanding of embodied carbon, because heat pumps are fantastic. We see utility consumption greatly reduce from heat pumps, but heat pumps have compressors in them. Now you have compressors everywhere instead of one. So with our design to reduce operational carbon, I think our embodied carbon is going up. Similar and a little bit same but different, but mass timber, working on a project that's mass timber. They got it from Austria. And I'm like, okay, so timber from Austria is better than steel and concrete from right down the road. And end of life for mass timber, we're still figuring that out. So these are all great ideas, but I think in 5 years, we'll have a better understanding of embodied carbon, the balance of embodied carbon and operational carbon. I don't know that we'd laugh at it. We still want to do our best. But I think that embodied carbon understanding, and as a side note, AIA 2030, our commitment to get to net zero, I think it's going to get pushed in that 2040.
All right, Andrew?
So two things. I think it's people hitting auto pay for the utility bills. Just with the increases we've seen, I feel like you're going to be, you notice those big draws on your bank account, right? Whether it's a business or a homeowner, right? And I feel like people are going to start really thinking about it. And then secondly is, people are going to have to learn to understand that. Specifically like homeowners, small and mid-sized business, right? Where they're going to be looking at these things like their kilowatt consumption rate, because you're billed for that on a larger scale, and then your kilowatt hour consumption as well, and they're going to be looking at things like heat pumps without having Dave come in and be like, hey, we're trying to get this certification. They're going to be like, hey, like I need to do something because this is the equivalent of me making less money every day when this happens.
Excellent points. Excellent points. So now we're going to transition to the open Q&A, and I'm going to invite Jesse back into this conversation to help me with that. And I see that some have already added some questions into the chat for us to address, and I would welcome more of you to do the same or raise a hand to be unmuted and ask our panelists directly. Jesse, you want to kick us off?
Yeah. Sure. Ben, I know you had a few questions here. So again, I invite you to come off mute and maybe ask them in order of importance to you. And maybe while you do that, I'll just start with one, which is directed at you, Andrew. That is, are you seeing an interest in solar storage? So solar plus storage at a building scale, not a utility scale. He's saying that we've only seen this in limited conversation where owners will pay 50% plus of their bills to demand charges. So from your perspective, what are you seeing in that regard?
I'm going to refer back to the tool belt. So it right now, right, kind of like Dave's 5 to 10 year rule from California, like in the East Coast for that matter, where this is being done at such a larger scale, right? You've got to have the right use profile, like with your amount of water and how fast you're pouring it out. Typically, if you have the big pours that are short, right, you know, the big swings in power, that's when it makes sense. Otherwise, you know, the applications we're seeing interest is more resiliency, which has a lot smaller financial benefit, unless you have like a critical manufacturing process that if the line goes down, it equals X amount of dollars. But two, right, talking with some friends in the industry, like in Washington State, some of their utilities have programs and rates specifically for batteries where as a business, you can install X amount and they have a contract with you to say, hey, if you keep this ready to go between 4 and 8 p.m. when our grid sees the max draw, and we can rely on you for 200 kilowatts for 2 hours, we're going to pay you. And it's a lot of money, more than you would get from the savings of implementing it yourself. So, you know, as things shift and time goes on, I think Midwestern groups are going to learn from that. Both, you know, businesses, service providers, municipalities, schools, etc. If that answers your question.
Mm.
Absolutely.
Yeah.
I wanted to circle back to something we hinted at earlier, Dave, about the idea that it's a little bit more intensive and cost burdensome to retrofit an existing building into electrification and taking really big decarbonization steps. So what, for those who are listening, you know, especially knowing the makeup of most of SBC's membership, you know, if someone's on the call here that is sitting in a industrial or manufacturing site that's 20, 30 years old, what approaches are really best for them to move forward with upgrading their buildings with this in mind?
Yeah, I think it's the same approach for every building type anywhere in the world. I've had several years of energy auditing experience as clients ushered through the lead for existing building rating system. And you just know your building. What's your building operating plan? When is it on? When is it off? Look at your HVAC system. Look at your MEP systems. Do they match? Are your HVAC systems run nobody's in the building? We'd show up to buildings in the middle of the night, and anything that's on, you got to explain, why is this on? So just know your building through a building operating plan, through your systems narrative, how it's heated and cooled, ventilated. Look at your preventative maintenance, understand what that process load is. A good example I've come across with my factory experience is if they have a steam boiler, we ask, what do you do with the condensate? And they'll say, well, we dump it. It's condensate. No, we take that hot condensate and we find other ways to heat the building with it, which is significant. So with large factory sites, old buildings, know your building, find ways to recover and reclaim some of that heat, and then look at where there's potential for PV on the site. Unfortunately, it's not. You're always limited to what you can do with industrial because you have to make your widgets and those consume a lot of energy. But as always, just know your building, and kind of just touch on Ben Austin's question is industrial sites aren't the best for geothermal because if you're always dumping energy in, you got to have a balance between your geofield and your building. That's why it's nice here in Wisconsin. You got hot and cold, goes back and forth. But if you're continually dumping heat into a geofield, it's not going to be a good fit.
Yeah, thanks. Go ahead, Ben.
Yeah, thanks for the conversation. And Apologize for brain dumping into the chat. I was feeling the energy.
Appreciate it.
I am curious, the electrification business cases to reduce carbon emissions, to your point, Dave, in the long term, knowing today we haven't seen that make sense, right? So I'm curious, data center development, energy and utilities just being very dynamic at the moment. Like, I'm wondering if you're leaning on any tools to help inform, knowing that that is a crystal ball. Like, is there anything you can look at with any kind of clarity, or a tool that has more real-time feedback loop to maybe what's happening in the market as you think about what that electrification decision could look like moving forward, knowing that there's probably not a perfect answer?
Yeah, that's a good question, because people will say, well, okay, it doesn't make sense now, but when will it? And that's kind of the crystal ball question. There's a website, NREL, N-R-E-L, and I can share with the team. It shows you the future expected emissions of the various grids around the country. So we can put it through that calculator to see, how that looks in the future. It's also granular to the hour of the day and month of the year. And what I found fascinating with that is we can see what's the expected future emissions from the grid, but we also can see that the grids are cleaner during the day. And I thought, why is the grid cleaner during the day? Oh, it's all the PV. PV doesn't work at night. I forgot about that. But wind works all the time. So it's an NREL, National Renewable. I can't remember that it's an acronym, but I've got a link to the future grid emissions.
Yeah. That National Renewable Energy Laboratory.
Okay. Yep.
Good folks over there.
Mm-hmm.
Ben, do you also want to ask your question about do you think it falls with architects to navigate the early conversations with owners?
Yeah, right. I work for Findorf, we're a contractor. I acknowledge the many blind spots we have when we're engaging in these conversations, right? I lean on someone like Andrew to inform the details of solar feasibility and production and a bunch of the details there. So I'm just curious, Dave, this one is kind of directed at you. You and I have been back and forth on the code updates. And there's a bunch of new stuff project teams and owners are being required to do, testing, inspections, etc. I'm just curious, like, does that fall back on the architect ultimately being the first one in the door in your perspective? Does this open up to like a need for more building level subject matter experts, owners, reps, etc.? Maybe it's more of kind of a consultancy versus traditional architects, engineers, contractors. Like, where does this all land to support owners making informed decisions on projects?
It's a mixed bag, and complete transparency. We're working on each and every day to make that simple for the owner, get the right folks on board as early as possible. We've authored our spec to align with it, but we don't want to lean on a spec to say, here, Ben, figure it out. We don't want to go to a general sheet and say, peel off IECC 2015 and put on 2021 and think we're covered. No, we want to have this discussions, to your point, is what special inspections are required? How do we get the right folks on board? What is the cost of this? Building envelope commissioning. We, as a design firm, will not house that contract, but we make the owner aware of it. On the GCCM side, where you're coming from, Ben, I've seen it both ways. They will house that contract and include it, and some GCCM say it's not our responsibility to have the fox watching the hen house. We will not provide that. So it's just that early discussion from an architect's perspective with the owner and owner's rep to say, hey, just to make you aware, this is the new code. Here's some of the things we need to do. What would you like to do? And then we have that discussion with the owner and make them aware of it. And to your point, we need more experts now than ever. And we'll call it sustainability or called cold consultants. These are new to us requirements. And I've said this again and again for the last several months that we've adopted these new energy codes. Is it's different in the sense that it's just not more efficient MEPs. It's not just more efficient glazing. We get all that, but now we need energy credits. It feels like LEED because it depends on programmatic space type. It depends on where the project's located. We have building envelope commissioning requirements. We have MEP commissioning requirements. It feels like where LEED trailblazed 15, 20 years ago, our codes are finally catching up, which puts me in a great position because I've been doing LEED since the 4th grade, but now LEED V5 came out and I kind of start from square one again.
You're welcome, Dave.
Yeah, thanks. Karen.
I know we're gonna thank you everyone for the questions and Dave and Andrew for the discussion. We'll need to wrap up in the interest of time, and I'll hand it over to Jesse. But I just want to say that it is really important when you're pursuing this work that you are finding service providers and practitioners that can navigate this very dynamic industry and these changing components. This is something where you do want to find a seasoned group that can help you do this, because as you can tell, that this is not a copy paste solution. This is unique to every site. This is unique to every climate. The use inside the buildings, you really need to find teams that will support you in making those integrated, holistic decisions. And between the membership of the U.S. Green Building Council and SBC, our member directories have those experts right at your fingertips. So I would highly recommend that you connect with our speakers today and connect with those members, and just know that I'm always available to answer any questions that you have, and I feel confident that our speakers today would do the same. So with that, Jesse, I'll hand over the mic to you.
Yeah, great. Well, thank you so much for sharing all of your expertise. Really appreciate your time. I was just going to sort of say from my last comments that I have this conversation with Ashley at Train all the time. I feel like she's on a mission to make sure that there's more conversation up front about the needs of owners, from the contract to the architect, from the contractors, right? Because, in her vantage point, she's always seeing how, whether or not the owners are aware or want these things, there's still problems with the knowledge gap of some of the contractors actually doing the work or not providing what has been spec'd by the architect. So it is kind of like, to your point, it's not a one size fits all, and we need to continue to have these conversations. I was just at an event where Milwaukee County shared that they created design standards, and now every project across the county has to go through a process to make sure they're doing design standards. And I was like, every business should do that. Every business that cares about sustainability, whether you're retrofitting spaces, whether you're doing new projects, whatever it is, just think about that as a way to solve these challenges and to help be proactive across the organization, especially if you have a larger portfolio, especially if you have older buildings, to get the energy audit. It helps. It's just a great process for allowing you to get your goals met. So that was my tip for the day. And then I just want to encourage everyone to stay engaged and involved with us, with USGBC. Corinne, to your point, people sometimes ask me, can you curate a list of vetted contractors? And I was like, yes, it's our member list. So make sure to go out and look at those who you can work with and talk to that speak this language already, right? So I'll wrap it there. Yes, we encourage you to stay engaged, join us at an upcoming event, and we hope to see you soon. Thanks so much, everyone.
Thanks.
Thank you.